Hello and welcome back to Compiler Programming. In this video, I think it's time we slightly improve our pointer support. And in particular, we have ability to sort of manipulate pointers. If we look at our value type, like we have a pointer descriptor. However, we don't really have a way to create a pointer to something, right? Because we just have values, but we can't really pass them around as pointer to some other functions. And the way it works is we will need to use a special instruction that is called LEA, or load effective address. Basically, you give some memory location to that instruction, and it loads the address of that memory address. Yeah, it loads that memory address into the register. And the reason you need that is because like if you know absolute memory address, you don't need this. But if you manipulate some stuff that is using either REAP relative addressing, or it uses something on the stack and you want to get like absolute pointer to it, then you need this instruction. So let's figure out a small test maybe to check if we can actually make that happen. I will probably do a slightly modified test for Hello World, and basically I will want to try to put an array of 4 bytes on the stack, and then take a pointer to that array of 4 bytes, and afterwards try to pass it again to this puts function and see if that works. Yeah, let's just start. So we will need to move some stuff around from what we had before. We no longer have this message overload, I guess. Instead, I will sort of cheat and abuse the fact that I know how stack is aligned, and try to just allocate a value that is going to be like 4 bytes essentially, and manually write out the 4 bytes of the string in there. Obviously, later on we would want to support strings or arrays for that matter properly, but having generic support for putting values on a stack is something else entirely, and we will deal with it at a later point in time. Okay, so I guess the way I can do this is to create or maybe we can try. Let's just try how bad it is, and if we need to do some hacks, we'll do some hacks, but otherwise let's try this. We say that we need a descriptor. Well, let's gonna call it message descriptor. The descriptor is gonna be a fixed size array descriptor. So it doesn't even need to be dynamically allocated, so it's perfectly fine if we do it this way. We say type is this thing, and then array, what is it called? It is called array indeed, and the fields are length and then array of descriptors. This actually should be star as well, so it should be array of pointer to descriptors, but it sort of doesn't matter. Actually, no, this is a single descriptor, so it's fine. Okay, array for this array. Length is 4. And descriptor is descriptor S8. So bytes is S8, 8 bits. Good. Now we will remove this for now. That's okay. We don't need puts value then for the moment. This also goes away for now. And as does this. And right now I'm just gonna try to make this array of 4 bytes, shove it on the stack, and yeah, and make it happen. Okay. So we need stack. It's called stack, right? The generic form. What do I need to pass to it? I need to pass ID, descriptor, and a value. That's fine. We can do that. So ID is gonna be message. Then, or we can even say message value. Then we need the descriptor. So that's our message descriptor. And now the value. And this is going to be slightly tricky. As I said, because so far we haven't dealt with immediate array values. And we don't really know what to do about them. I think I will cheat for the moment, and for the value, I will just say value from S32 and put there basically this. It's gonna be slightly yuck. Let me show you maybe more precisely what I'm doing. So we have U8 high, and this is gonna be like this. So strings are just arrays of bytes, right? So if we create an array here, like so, we can also turn it into S32 and say hi int and hi or hi S32. And hi S32 is literally going to be we take the address of the array, right? We turn it into a value, or actually better do it like this. So yeah, we take the array, we reinterpret it as a pointer to S32, then we copy the value that is going to be these 4 bytes, whatever that integer ends up being, and it doesn't really matter. And then we just use that integer as the value. Okay, let's try to build this. I think that stack will tell us that we are doing something really weird, but we can hack it in, I guess. So missing function header. What is going on? Sure. Did I mess up some braces somewhere? I guess. Otherwise, I'm not entirely sure. So let's first try to comment out everything and see if that builds. Okay, that builds, and now we can just comment out one by one and try to understand what's going on. So it doesn't really like this. Yes, because here it's supposed to be a comma. Descriptor is not a member. Indeed, it's not. Okay, that's fine. Value overload star. And yeah, our stack actually expects an overload because it uses move value. I guess that's fine. Maybe though, for this particular test, we will do it manually and then figure out how to extract this into a reusable functionality. Is that because we are not doing exactly what the thing expects us to do. So let's just do it manually first and then see how it goes. We reserve stack, and then we will need to move it there. And since we will need to move it, we just ignore this stuff and do the move. So move value of builder, then this is gonna be message overload. And then we have whatever we want to right there. So this is going to be S32. Good. That sounds good to me. Let's see what's going on. Okay, it builds, but I assume it will assert that we are trying to do a weird assignment, which it actually does not. And I think that's because move value actually only looks at the sizes. Yeah, so move value looks only at the sizes, and this is actually good for us right now because we don't really care that there are different types. Like, I'm doing weird stuff here anyway, so it's good. And now, as I said, so we have this this value. We can probably even look at it to check if it actually makes sense. Let's open dev environment, mass solution. There's going to be a bunch of typecasting to get to that value, but we still can try to do it. We need to open function spec now and get to here. So we are calling this. Let's start. I'm a bit confused. Oh, yeah. It tries to run a different thing because now we have two executables. So now I will need to do some changes. Much better. Step into the function, and we have this move. So if we go to watch, we want RSP plus 14, and you should treat this as char star, and we don't need star anymore. Okay, so see, here I'm not sure like if I can zoom this somehow. I guess not, but basically it says hi, and this is exactly what we want. So our little hacking actually succeeded, and in general sense it's not really a hack. When you initialize array values on the stack, this is more or less what you do. Like, you would try to do the minimal amount of move operations. So you would use 64 bits or even SIMD moves to like shove memory as fast as you can, and without looking at individual elements. So even if our array is an array of bytes, we would still try to like fill it in multiple things at a time. So this is something like this is more or less what we will end up doing anyway afterwards. But right now we are just going through the motions manually because our goal for today is loading the address of this. Okay, we can close this down. Everything looks okay. But now, hopefully, if I try to actually call this with this, I hope to see an error, an assertion, because like we are not passing a pointer. And I hope we catch that in our checks, but let's see. Okay. Well, it actually says that no matching overload found. Yeah, which basically means type mismatch. This is a bit of a not the best message I come up with in this project, let's put it that way. But what it says is it should be a pointer. Okay, how do we make the pointer? So we will need to have value pointer 2 and do something here. We'll first implement it in function and then figure out what would be the best place to put it. In a sense, it will probably turn out to be a macro anyway, because we will need to pass a builder to it. But for now, again, we're just doing it manually, so we can figure out how that works. So value pointer to, it accepts a function builder, just gonna be builder, and then it accepts a value star value. Okay, and it returns also value. We do the standard dance with overloads that to extract a single one. So maybe get a single overload of value, assert I think I'm almost ready to change how this works and make it so that value is an overload like I originally thought about this, because this is getting a bit tedious to type in. Okay, and now that we have an overload, we want to to get a pointer. We will need to check what is the type of it, I guess, and where it is located. So we want to assert, like later, to do support registers, but for now, and I don't want to deal with this stuff, so I want to support registers and support immediates. So for both of those, we will need to actually allocate stack space, put it on stack, and then take an address of that. But for now, we assume that whatever is there is already on the stack or in memory. So we do assert overload operand type is not operand type register and not operand type immediate 32 and not operand type, do we have immediate 8? Yes. Okay. So it is now basically a memory, because if you look at the operand types, it's not register, it's not immediate. We also should do immediate 64 to be thorough. Essentially, maybe we should assert that it's one of these two. Maybe that would be a better thing to do. So we do assert overloads operands type is this, or something like that. Sounds good to me. And the reason we are asserting that it's one of those two is because those are essentially memory operands that we can put here, because this instruction only allows us to put memory as a source of loading the address. Like you can't take an address of a register, you can't take address of immediate, but if you forced to take an address, it means that you would have to deal with that. Okay. Now we can encode, and we put builder. I already forgot how encode looks like, so let's just steal one from somewhere else and do it this way. So encode Leah. Obviously we are putting it inside of the register, but we will actually create a temporary value anyway, so that's something to do. So we also will need a result descriptor, and this descriptor star result descriptor is descriptor pointer to whatever was the descriptor of the overload. So like so. And we also need this register stuff, so like so. Okay, register, value register for descriptor, result descriptor. That's good. So it goes like this. We get a value, we check that it's a memory, we say that the result of this operation will be a pointer to that memory, then we create a overload for the register so that we can execute this Leah instruction. We load the address of this value. So we say overload operand, right? And then we move it out into a temporary variable, because like we always use register A, remember? And we can't store anything there, like it wouldn't really work. So we create this temporary stuff and we return what we need to. So move value to result of what is it? It's gonna be reg A operand. That sounds good. And we return of result. Okay, let's try to build this and see what is going on. Cannot convert operand. Yeah, so Leah does not exist. That's the first thing that we need to fix. Let's do that. I will put it next to move because they usually go in together in a lot of places. Okay, and our code is 8D. And then the operands are register. We actually don't have strictly memory operand. So this is something we also need to add for this to work, which is good. We are extending our support. But I guess for us, yeah, it's not here that we need to add memory. It is here that we need to add memory. Okay. So where was I? Yeah, Leah, it has a register and it has a memory. That seems now good. Its extension type is register. That is correct. So this again /r means that it's going to be this extension type. And now we need to also change our encoding stuff to know what to do about it. So if you essentially need to duplicate these two things, again, maybe there is a better way to do it, but for now we'll just stick with what we have. Like oftentimes developers would look at this and say, oh no, this is too terrible, I need to immediately fix this. But the thing is that if it is self-contained like this in a function, it doesn't really matter that it's a bit ugly, and it only starts to really cause problems if it grows like huge, you know, you have hundreds of those, or if you start spreading this across multiple functions. But as long as it's like self-contained, whatever. Okay, what is going on here? We don't want operands, I guess. We want overloads, so it should be register A. And we at least compile, which is good. Let me take another look at what is going on. That all looks good to me. I will build this, and then I will straight away go into debugger to see what's going on. Okay, so apparently we cannot even encode the function because of some mismatch. And the mismatch happens because, yeah, so the issue is, I think we have a pointer to an array, and the function expects a pointer to just a character, and C treats both of those things as the same. We probably should too, but I'm not exactly sure what is the best way to handle it. First, let me verify that it's actually the case. So if I look at argument list, and this is the first thing, overload list, descriptor, this is a pointer, and it's a pointer to, yeah. So this is a pointer to array. And if we look at the, no, not this one, to call overload list, descriptor, function, argument list, descriptor. It's a bit of a long thing, but the point is it points to an integer that is this has 1 byte size, which is a character or byte. Okay, how do we deal with that? I guess one way would be to have a special case for this in here and allow this conversion. So where we check, where is it? Same type. Yes. So if a pointer to type is descriptor type fixed size array, that's even a great autocomplete, and what? And a so let's just say, oh no, it's not going to be really shorter. So this will be a large if. The idea is we will do exactly what I said. So we will check if we point to a fixed array size that has an item that is the type, and say in this case, yeah, it's fine. We treat those as the same thing. We basically discard the fact that we know that it's an array of certain size, and we just treat it as a pointer to whatever, again, which is exactly what C does. So a pointer to so it's a descriptor. It means it's going to be array dot this dot item. So this is the type of an item array, is the same as b pointer to, actually, like so, same type item and whatever b points to. If that is the case, then we return true. We also have a reverse case, right? We have b points to a sized descriptor, and we say that if they are the same as what a points to, then it will be the same. And if both of them point to fixed size array, then the general case will just handle it. Like, this is perfectly fine. Okay. It does build. Let's see what is going to happen if we try to run this. Function spec, start. Okay, so we are past this check, so our code is correct, at least in that regard. Now let's see if load effective address is as good as the rest of the code. Okay, so we can load stuff, but the offset looks pretty messed up. And that's actually an interesting question. Why? So the problem is that like this is not a correct way to deal with this thing. And I think I know what is wrong. In the encoding, yeah, we have this special thing for RSP, because when we encode RSP as a memory address, we cannot really deal with this stuff. So I guess we will need to remove this assert or extend this assert. Say that operand type. No, actually this assert is fine, but here we would need to add another thing and say or memory. In either of those two cases, we need to do stuff. Do we have any more things that deal specifically with register memory? Doesn't look like we do, only ifs. Okay. We build again and we try again. Assembly, tink, 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 much better. I think. So as you can see, well, we load a lot of them. This is kind of strange. Why does it happen 3 times? So this is very interesting. So this is value pointer 2 to run no loops in here. We encode Leah only once. I don't think anyone else even calls this function. How come we have this weird oh, I'm really confused right about now. What is going on? Let me try to remove this. Yeah. I know that I'm not using puts value. So disassembly. Okay. If we don't call pointer to value, the code is basically what you would expect it to be. Okay. So let's split this up. Value star message value is this. Then we have a call. We say value star message pointer value is this. And then we call. Okay. And now I want to basically look what happens over here when we do value pointer 2. Yes, I want to look at you. Let's start. The first thing is you can look at the buffer. Buffer occupied is 18. So much. We only have done reserve stack. The buffer should really be free. No, it has an add instruction, but this is only like 4 bytes. I guess it also, yeah, it also moves the high in the, yeah, okay. I can believe that. That's fine. That also seems fine. 8 bytes for an instruction seems okay to me. Then we reserve stack, remove value, and we return. That seems fine. Now we call this. Okay, what is inside builder? 62. No, I don't want hexadecimal display. I want to Yeah, okay. So it has this sub RSP, the word. Yeah, so right now this function looks like what I would expect it to look like. Why doesn't it look like that later? Okay. Really confused right about now. Okay, now it looks correct. Not sure what was happening there, but I'll take it. We move the value to this plus 34. So now I need to change this if you want to see it. So yeah, we have high in the right place. We load the address of high, which should be this value, right? So if we look at array X now, this is exactly what it is. So see, this value matches this value. Now we put it in on the stack for safety. We put it in RCX here because this is the first argument. And then we move address of puts in arrayX and we call arrayX. And then we return the value. And let me move in this test window. You can see high is printed as it should. So that's a win. I'm really happy with how this turned out, apart from that weird detour with multiple stuff on the stack. But maybe I just didn't save a file or something like that. Anyhow, that looks good. We have all the tests passing. We have a way now to get a pointer to a location in memory, which is good. So that's it for today. Thank you very much, and hopefully see you next time.